Hello and welcome to this physics video, Simple Harmonic Motion U08.SHM2, and today we will be applying the conservation of total mechanical energy to solve problems involving springs. We will be using the energy consideration to examine the connection between velocity and displacement for mass spring systems. So the total mechanical energy of a mass spring system is right here. 1/2 kx squared plus 1/2 mv squared. The 1/2 kx squared acts as the potential energy, and the 1/2 mv squared acts as the kinetic energy. So let's try out a problem. A mass spring system has a block with a mass of 3 kilograms moving at a velocity of 13 meters per second. The spring constant has a value of 190 newtons per meter, and the block ends up traveling a distance of 7 meters. What is the total mechanical energy of the mass spring system? Okay, so here is our equation again. And let's plug in what values that we know here. We have a spring constant of 190, a displacement of 7, that's going to be squared, plus 1/2 a mass of 3 kilograms, and a velocity of 13. So that's mechanical energy. Now we just have to put all of that into our calculator here. So we get 0.5 times 190 times 7 squared plus 0.5 times 3 times 13 squared. Okay, and that's our value. 4,908.5 joules, because that is energy. So there we have it. Let's try out another problem. Now let's actually analyze the connection between velocity and displacement. What is the total mechanical energy of a mass spring system if the spring constant has a value of 71 newtons per meter and the displacement of the mass is 8.1 meters? The mass is not moving. So the mass not moving is very important to this problem, because as we write our problem here, or our calculation here, we see that if the velocity is 0, then the whole kinetic energy part of this equation is going to be 0. So you're only left with the potential energy. So what this is saying is when the velocity is 0 here, the potential energy is reaching its maximum. Likewise, if the potential energy were to reach its, if the potential energy, let's say the displacement was 0, the kinetic energy would be at a maximum. So now let's try calculating this. We get a spring constant of 71 and a distance of 8.1 meters squared. Put it into the calculator. 0.5 times 71 times 8.1 squared. And there we go. That's 2329.1, and I'll just round that to the 10th 2. And joules. And there you have it. We just did problems using total mechanical energy and looked at the relationship between displacement and velocity. So thank you for watching, and I hope you enjoyed the video.